Title of the paper is A Framework to Detect Twitter Platform Manipulation and Computational Propaganda. And author of this paper is Nishan Chathuranga Wickramarathna. And Nishan holds a BSc Honours degree in Information Technology from Faculty of Information Technology, University of Moratuwa. So we will move on with the recorded presentation, and after that the Q&A session.
This is a framework to detect Twitter platform manipulation and computational propaganda, and this is for the paper ID 107. These are the set of authors who presented the paper, and our supervisor is Dr. Upeksha Ganegoda from University of Moratuwa. So for starters, I'll start with what is platform manipulation. It is refers to the use of Twitter to mislead others and disrupt their experience by engaging bulk, aggressive, or deceptive activity. This activity includes, but is not limited to, spam, malicious automation, and inauthenticating account abuse like fake accounts. So as per the Global Disinformation Order report provided by the Computational Propaganda Research Project, they have identified that social media manipulation campaigns which have taken place in 70 countries, which is up from 48 countries in 2018 and 28 countries in 2017. In each country, there is at least one political party or government agency using social media to shape public attitudes domestically. So here also see the different demographics in each of those mentioned years. You can see that there is overall 150% increase in the countries using organized social media manipulation campaigns over the last 2 years. So to tackle this problem, the framework that we have come up with is this. So here module 1 corresponds to creating keywords, extraction, and collecting relevant news. So what it does is collect this set of keywords from a tweet given to this framework and use that set of keywords to collect the relevant news or relevant tweets from the Twitter API. And all those collected news or tweets will be feeded into this module 2, deception and automated account detection, and also for module 3 and also to module 4. There is a dependency between module 3 and module 4, which gives some parameters to module 4 from module 3. So first of all, keywords extraction and collecting relevant news. So for this, a corpus was created which consists of more than 100,000 tweets collected via Twitter API and Kaggle. So this is what we wanted to do, is to make it as generic corpus, because existing corpora are built with tweets either domain specific or have less data. So we pre-processed those collected tweets. After pre-processing, you can see that we have reduced all those unnecessary words. So for the keywords, as I mentioned earlier, we need keywords to get the or the query the Twitter API, so that we can get the relevant news or relevant tweets from the Twitter API. So important keywords in a tweet are such as person names, locations, organizations, dates, and other nouns likewise. So the design of the module is as follows. The claim tweet or the initial tweet will be input as a parameter to the algorithm, and after the pre-processing text, we will take the keywords. To do that, we do NER tagging, person names, locations, organization, dates, nationalities are filtered using that. And Stanford Core NLP toolkit was also used to get NER tagging, since it has 7-class model tagging. So this and Stanford Core NLP toolkit is a free open source toolkit that we can use. TF-IDF statistical method will be applied on the remaining words using the corpus, since there could be important words that had been missed in the previous steps. So after the extracting those keywords, then we do synonyms. So because using Gensim word to egg, because some same news can be posted by using two different words. Similarity index had been determined using a statistical experiment. So after we extract these keywords using the mentioned methodologies, we use the Twitter API to query, and then we get set of tweets referencing that specific context. So to evaluate this model, we use Turing test. Turing test is so we use a set of participants, and then we give them the tweet and the extracted keywords from that tweet, and they will score the output based on the similarity or the relevancy of that specific tweet. So we use several type of participants to do this, and we have observed that successful percentage is 63.36 using this method that we have used. And when it comes to deception and bots, first of all, let me give a brief background regarding this. On 3rd of January 2020, United States drone strike near the Baghdad International Airport killed Iranian Major General Qasim Soleimani. After the incident, Iran strike back with 15 missiles launching on US targets in Iraq, but there were no casualties. A fake news was propagating through the social media, saying that at least 80 Americans were killed. So this is example of social media information operation carried out by Iranian government. So to accomplish such kind of scenario, there are multiple kind of bots that they use. So puppet bot, as the name implies, are controlled by a human. Then amplifier bot retweets and spread that tweet into a wider audience, and then approval bots come and react on those tweets, so they will have higher number of likes, so the people like you and me will consider them as credible news. So to identify these bots, you have to keep an eye out for number of links, number of hashtags, and they tend to make grammatical errors. And also the context is also everything, because the tweet is usually these mass media campaigns are targeted toward some important event or important news happening around the country. So to tackle this problem, we have, first of all, we are trying to identify the deception. So to identify deception or the fake or the authenticity, we have used two data sets to train the models. We used logistic regression, multinomial naive Bayes, and count vectorizer together with TF-IDF, and their combinations to come up with a better solution. We have identified that using different data sets, the output is different. So that means, depending on the domain, the authenticity could be different, right? So meaning that I would be tweeting authentic content on another one domain and false information for another domain. So there could be instances like that. That is why the output is differencing as we perceived. The word count contributes the most positively to being non-credible is incredible, as you can see. And the word count contributes most positively for being in the credible, it is arrested. So likewise, you can get a number of frequencies and what are the words that are contributing to distinguish these tweets from being credible or non-credible. Then what we do is, obviously, of course, we give what is the credibility of the tweet first of all, and then we use the most used terms in non-credible use, and then we subtract most used terms used in credible news. So what we get is the most used terms appearing only in non-credible news. Then we look for these words in the attributes of a tweet or a user account. Say the user account has description. So if one of these words are appearing in the description of that user account, we assume that that account or that tweet could be a bot account, could be tweeted by a bot account. So that is what this domain linking part do. So let me just tell you that the first feature, this feature that we derived using this most used terms in non-credible news alone increased the model accuracy by 1.36, and all the other engineered features resulted in 2.69 increase. So these are the created features. So you can see there are some features called binary features. So as an example, description binary. If the description binary is 1, that means the description contains one of those mentioned words appearing in non-credible news, right? So the NA features are null features. So likewise, we can identify what are the different features and what contributes to the output the most, right? So after creating the credibility or after getting the bot or non-bot output, we move on to creating impact and the credibility. So to create the impact, we see that the impact is usually negative or positive. So based upon that, we create agreement score, dividing number of positive followers responses by total number of followers responses. So these positive followers responses are created using sentiment analysis. And apart from the sentiment analysis agreement score, we use another feature called the news category. Again, this is derived from a machine learning techniques that we can put a tweet into different categories like sport, political, etc. After creating these features and set of features available in the dataset like followers count, we use a clustering algorithm to divide these user counts into 5 different credibility baskets. So if a tweet comes as 1 or an account comes as 1, that means that user has less credibility. If a tweet comes as 5, that means that account has a higher credibility. So yeah, as I mentioned earlier, this is clustering algorithm. Here also see the same methodology in a more descriptive manner. So as you can see, we have identified that 70% of overall accuracy has been generated using this complete module, which is the credibility module. So as you can see, these are the categories that we observe in the tweets, and these are the tweet users. So as you can see, if it is CNN, you will get around 4%, right? So if it's a person or a individual entity, you will get like 3 to 2 kind of credibility rating, right? And when it comes to the forecast, what we do is we are trying to get hold of a number that this amount of tweets will be in the future. So at the start, the tweeting regarding one specific news event could be 100. So what we are trying to do is at the end of this event or this social media phenomena, there would be this amount of tweets, like say for an example, 200,000 tweets will be available in the network if once this event is over. So to forecast that, we use recurrent neural networks. We collect data in different timestamps, and then we feed that data into a recurrent neural network. So to do that, we divide the initial data set provided by the module 1, and then we divide them into different timestamps, 1 day, 1 day timestamps, timestamp baskets, and then we get input those tweets into the recurrent neural network, which is LSTM, and then we try to come up with the number that this event could be reaching this amount of tweets. So as I mentioned earlier, so this implementation was LSTM. We can also more extend this module to be generalized prediction model through layered stacked LSTM. So these are the features that we are using. As you can see, this categorical component feature ratio comes from the module credibility module, and also this positive implementation ratio is also coming from that. So yeah, so there are 14 different features that we feed into the neural network. So at the end of the day, we observed that there are low number of error matrices. These are also that we observed that these are very low comparing to what we are seeing at the current models that we have observed in the literature. So all those 4 modules are at the end creating different outputs. So these outputs will be guide the user to get a educated decision on whether to trust or disregard this content that he has come across. So yes, that will be our research. Thank you.
Okay, thank you, Nishan. Now it is the time for the Q&A. So, any questions from the audience? Okay, Nishan. So you have mentioned that you have worked with them with some set of features. As your paper says, it's 24 features. You have created 24 features from the data provided by the Twitter API. So, on what basis have you defined these features?
So yeah, so the basis is actually the research of the paper, because what we think is if there could be a word or a phrase that is appearing in non-credible news, so and that same set of words are appearing in the data provided in the Twitter API, say for an example. So you usually put a description in the Twitter profile. So if your Twitter profile contains any of those words, so this user could be targeting or using the Twitter to mislead others. So based on that assumptions, we created the features, and also we used null features, which means that if you don't have a profile picture, there could be a high chance that you could be a bot account, right? So if you don't have a description or a location mentioned in your tweet profile, there's a high chance that your profile could be something inauthentic account. So that is the basis that we took into account when we are creating those features.
Okay, thank you. So, any other questions? So it seems we don't have any other questions. So thank you, Nishan. So we will show our presentation for him.
Thank you very much.
Okay, thank you. So that concludes the presentations of our session. So thank you all the presenters and for those who have participated in this session.